Hello, class. Welcome back. We're doing volume of pyramids. Yo, at the end of the last video, I teased maybe next would be cones. Maybe next would be pyramids. We've done prisms and cylinders. Pyramids, it is. Now, I wish, like you in some ways, I'm sure, that we were back in class doing this in person. If we were, I have these wonderful three-dimensional objects that I've been filling with water every other year I've taught this, and you could sort of dump out and take guesses from everybody as to how many different pyramids do you think would fit in the same prism if they have the same base and the same height. Because if you work backwards, then the pyramid formula ends up being that fraction of the prism. Well, take a moment right now and just think. If I had a pyramid and a prism, and they had the exact same base, they had the exact same height, how many of them do you think would fit in the prism? How many pyramids, same base and height, would fit in the prism? Take a moment and think about it before I say it. Do 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 do. I'm not going to sing anymore because of copyright. Anyway, did you say 3? If you said 3, you're right. Because look at what I found. These aren't water, but you can see how this cube, this square prism, can be broken up perfectly into these 3 pyramid shapes. Same thing with down here. And then if you connect them, it would form perfectly a prism with the same exact base, like these 2 yellow bases on the bottom. That's a pretty cool visual representation of our situation today, which means the formula for an individual pyramid is, dun 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 dun, we've had prisms, we've had a cylinder. If we go down a little bit further on the page, there it is. We need to figure out the volume of the prism that had the same exact base, and then because there are 3 of them, we just divide by 3. So for a square pyramid, that would be length times width times height divided by 3. I'm not going to give cone away yet. If there's a triangular pyramid, you do length times width times height divided by 3, and then also divided by 2 because it's a triangle. Or we can do a little simpler, and we have one of those on this lesson, so I'm not going to say any more about that. I'll save it. If you haven't already, open up your Desmos calculator. We've got 9 problems to do today. Number 1, a pyramid and a prism have the same height and congruent bases. The volume of the pyramid is what fraction of the volume of the prism? Write your answer as a simplified fraction. Now, we just gave that away from our beginning mini lesson. It's a third, 1/3. Notice I just hit the little slash next to my right shift key. Don't use the one that's going up into the left. Use the one that's going up into the right. If you screw up, you'll have to redo it. It's 1/3, meaning, like number 2 is a lovely square pyramid, I can multiply my 3 numbers together like it was a prism, and then just divide by 3. And we learned last time you could do this in any order, as long as you're dividing at least some part of this by 3, you'll be right. And I'll prove that to you right now. I like putting the slash first. It just makes it easier to see. You can do it in any order that's comfortable for you. Either way, you're going to get this decimal. It's a little nasty, but we see that we're going to round to the nearest hundredth if necessary. Little decimal reminder, I've done this a few times already. Hundredths are really popular. This is the 666, little dark decimal. If we're rounding this to the nearest hundredth, I got to figure out, is it 0.66 or is it 0.67? I look at the number to the right of this line, which of course are all 6s, except for the 7 that's rounded up, which is another hint on what is going to happen to our 6. Why? Because it's 5 or above, 5, 6, 7, 8, 9, so we give it a shove, and it rounds up to 6, 7. And that 7 really is a cool indicator if you're ever confused on what happens and it's the same number the whole time. This last number either stays a 6, it'll round up to a 7, depending on whether it rounds up or not. And if this rounds up, well, then sure enough, if it's the same number, so does this 6. So I'm going to put 1620, which is very similar to the Plymouth Rock year that you're supposed to memorize in school when settlers landed on Plymouth Rock. Was it 1620? That's in my head for some reason. Somebody can Google it and comment down below on this video? Let me know. When did the Pilgrims get to Plymouth Rock? There you go. Successful rounding to the nearest hundredth. And once you have this up, you just sort of leave it for a sense of a model to follow each time. Find the volume of the pyramid with a base area, capital B, and a height, lowercase h. Capital B is 3 meters squared, so just like I said last time, when it's got meters squared, we know that's area. And the height is 15 meters, so that's height. The volume then is going to be the 2 multiplied together and then divided by 3, because it's a pyramid. So, a little slash there. 3 times 15. Oh, but this is one of those fun ones we can do in our head, because if I just divide this first one 3 by 3, I get 1. 1 times 15. It's going to be the same thing as if I do it the long way. You're going to get 15 each time. 15. And I'm going to demonstrate that on the next one, because 11 does not go into 3, but 12 does. 12 divided by 3. What is that? 4. 4 times 11. Oh, it's 44. And if that was too fast, you can again pause this video and just multiply them together and divide by 3, like we did the last one. Either way, you should hopefully see positive messages affirming you as a human, an individual. You win! Amazing! What do I win? This is like the one sport that's going on in the world right now. Ooh, this is the one I was previewing before we started. We have a base for the first time that's a triangle. Meaning, yes, we are going to multiply our first 3 numbers together like we've been doing. 22 times 14 times 17. But we're not just going to divide by 3, because that would be a square. Instead, we can either divide by 3 and then divide by 2, or, what's the same as dividing by 3 and then also dividing by 2? Well, it's the same thing as dividing by 3 times 2. And what's 3 times 2? Yes, that's right. Perfect. 6. I can hear it all the way over here in Milwaukee. You said 6. And 872.6. Oh, look, it's the same exact one I was talking about. It rounds up to a 7. We can see that on the end. What a lovely repeating decimal. And we are now also awesome, added to the list of things that we are in this assignment right now. Number 6, the volume of a pyramid is 24 centimeters cubed. The volume of a prism with the same height and base that is congruent to that pyramid is blank centimeters cubed. Well, if we know that there are 3 pyramids that go into a prism, we could simply just take our volume of our pyramid and multiply it by 3. It's that simple, because they share the same base and the same height. So just take whatever your number is for your volume and multiply it by 3. We're on fire. Somebody get the extinguisher. All right. 7. A hollow prism holds 120 gallons of water. A pyramid with the same height and base that is congruent to that of the prism holds blank gallons of water. Now we're going backwards. Instead of going from the pyramid to the prism, we're going from the prism to the pyramid. So instead of multiplying by 3, we're going to have to do the opposite, which is, yes, that's right, I can hear you again all the way over here. It's divide by 3. So take whatever your volume is on 7 and divide it by 3. It says to round to the nearest hundredth. Maybe you will if you get a number that's not divisible by 3, but we are a superstar whose number of 120 is, in fact, it divides evenly into 3. Number 8, it takes 93 minutes to fill a rectangular swimming pool with water. Interesting. A pyramid with height equal to the depth of the pool and a base that is congruent to that of the pool will take blank minutes to fill. Well, you'd have to think about how many pyramids do you know that you've swam in. Those would be very difficult to dive in. That's why, in general, it's a rectangular prism that you swim in, and that's why it says a pyramid then. So we are doing the same thing that we just did, since we're going from prism to pyramid. We're dividing. 93 divided by 3. Ooh, this is going to be evenly dividing by 3. A quick little mini lesson again. How do I know that something is dividing by 3 without even hitting enter, even if it's a super large number? Well, I'm going to teach you something real quick. Say I have any number in the world. I just wrote this. I'm going to add up the digits. 7 plus 2 is 9. 9 plus 1 is 10. 10 plus 2 is 12. 12 plus 3 is 15. 15 plus 4 is 19. So if I add them all up, I get 19. So the question, does 19 evenly divide into 3? Well, 18 does, so 19 does not, meaning this entire number is not divisible by 3. However, this is where I can cheat, because I know that 19 isn't, but I know 21 is. So if I add a 2 on the end to make it equal 21, well, now I could stand in front of any room and I could say, I know that this whole number here is going to evenly divide by 3. I know it. I don't know what it necessarily is, but I do know that it will divide by 3 because I added it up as I wrote it. So if you want to impress family or friends, and you know at least what's divisible by 3 up through, 18, 21, 24, just keep going by 3s. Or say 30. 30 is an easy one, 10 times 3. You can write out some number to your family and say you get to 29 as you're slowly adding across. You can wow them by saying, oh yeah, I know that's not divisible by 3. But then you add a 1 somewhere, anywhere in the number, and that number automatically will be. There you go. It's a fun little mini lesson. And 9 plus 3 on the bottom here for 93 is 12. And I know that 12 divides evenly by 3. Therefore, 93 divides evenly by 3. 31. And 31 is a nice prime number. Boy, math teachers are bored right now. Nice going. Thank you, assignment. Appreciate the affirmation. And the final one, Danny boy. He cast a bronze pyramid for an art project. The bronze pyramid had a square base with a perimeter of 44 centimeters and was 11 centimeters tall. The volume of Danny's pyramid was blank centimeters cubed. Round your answer to the nearest hundredth if necessary. Okay, this is a little complicated, at least compared to our others, which is why it's last. For this question, I am going to do the honor of drawing a pyramid. Here's how to draw a square pyramid. You draw a square on the bottom. And then up top, you make a dot. So I'm going to make a dot like right here. And then you connect each corner to the dot. And that's not perfect because it's a huge dot, but you get the idea. Now, the problem says that I have a perimeter of 44. Perimeter means that the outside edges all added together gives me 44. And this here is a square. Sound like a southern. This here is a square. And a square has all sides that are the same. So if all sides are the same equal 44, I can divide by 4, 44 divided by 4, and find that each of these sides are 11. So step 1, you could hit pause as you're doing this. Divide your perimeter by 4, either in your phone calculator or your Desmos calculator, to get the sides. So then that will tell me that each of these are 11 by 11. So I know that I need to multiply over here. 11 times my height, which is confusingly also 11. For you, I'm going to guess that they're going to be different numbers. Still divided by 3. And then we'll round to the nearest hundredth. Again, pause this video right now or take a screenshot, picture of your phone, something, because this is about to go away in 3, 2, 1, gone. Because I need to type this in over here. 11. 11 times 11 times 11 is the same thing as 11 to the third power. And I'll prove that to you by showing that. Manually, right below it. 11 times 11 times 11 divided by 3. It's still going to give me 443.67. Wow. I wonder if you guys have different rounding problems than I have. I just get 0.67 over again. You already told me I'm on fire. I'm indoors filming this. I should go outside and get myself cool again. Well, hope that made sense. Let's finish it as we always do. Make sure we see that perfect 100% come up on the screen. Hopefully you have finished yours and you also see 100% on your screen. As always, this was class away from class, and I'm wishing that you're all healthy, happy, safe, and well. Take care, and until next time, best wishes in all that you do, and much love from your teacher, Dylan.